Have you ever noticed that red and green LEDs were everywhere in the 1970s and 80s? Alarm clocks, calculators, dashboard lights. But nothing glowed blue. Not because designers didn't want it, but because it was physically impossible. For over 30 years, the world's brightest engineers couldn't figure out how to make blue light from a chip. But why? It starts with how LEDs actually work. An LED is a sandwich of two materials. One side has extra electrons, the other has empty spaces, called holes. When electricity flows, electrons jump across and fall into those holes. That fall releases energy, and that energy becomes light. The color depends on how far the electron falls. Red light, small drop. Blue light, much bigger drop. So to make blue, you need a material with a huge energy gap. And that gap has to be perfect. No cracks, no impurities, almost flawless at the atomic level. For decades, scientists tried material after material. Zinc compounds, exotic crystals, nothing worked consistently. Then, in the late 1980s, a Japanese engineer named Shuji Nakamura took a different approach. He didn't have funding, he didn't have a fancy lab, but he had one advantage. He could rebuild his own equipment. While everyone else used standard machines, he modified his from scratch. He added a second gas flow to keep the crystal smooth. He tested combinations no one thought would mix. And after years of trial and error, he created the first bright blue LED using gallium nitride. It changed everything. Because once you have red, green, and blue, you can make white. And white LEDs replaced nearly every light bulb on the planet. Your phone screen, street lights, TV displays, all of them rely on that one breakthrough. So the next time you see a blue light, remember, it took 30 years and one stubborn engineer to make something that seems so simple today. What everyday thing do you think we take for granted the most?